Hello, future engineers. This is on machines, and there are only two parts presented because the main principle is just free body diagram, and normally problems on machines are not so popular only for mechanical engineering, but most engineering field are not uh, fond of solving machines because on the first place, when we present problems on machine, the difficulty in drawing the figure makes the problem lengthy. And secondly, it is important for mechanical engineering field only. So this is intended for mechanical engineering, but the principles behind can be used also for allied engineering courses. The automobile bumper jack is designed to support a 4,000 Newton downward load. Begin with the free body diagram or BCD and determine the force supported by roller C. Note that roller B does not contact the vertical column, so the effect of the 4,000 Newton force causes B not in contact with the column. So therefore, we only have force at C normal to the column, and this 4,000 Newton, and it is the effect will be prevented by the reactions at A, pin reaction at A. So the FBD would look like this. So we have F sub C, and we have pin reactions at A, but we do not name the pin reactions at A because we plan to sum up moments about A. So moment A is 0, counterclockwise positive, so we have F sub C times 240 plus 100, so then minus 4,000 times moment arm is 400 plus 150 or 150 plus 400 mm. So we can now solve for F sub C. F sub C therefore is equal to 6,471 newtons. Determine the cutting force F exerted on the rod S here in terms of the forces P applied to the handles of the heavy-duty cutter. So we have details here for this portion, CDE. Take note that C and E are vertically aligned. The angle is 15 degrees, and the distance from C to D, which is also the distance from D to E, is 1.5 inches. So first, let's have the free body diagram of this part up to C to express the force in AB in terms of the force S, the force F exerted on the rod S. So here we go. So first we set moment C0. There's no horizontal component of force in AB. This is a two force body supposedly, so only vertical force in AB because this is a short link and it is vertical. So moment C equals 0, clockwise positive, so that is equal to F times 2 plus 4.5, so 6.5, then minus FAB times 4.5. Therefore, FAB is 6.5 over 4.5 of F, 13 over 9F. Then summation forces vertical or R vertical equals 0 to solve for F sub C. So it is equal to F minus FAB, which is 13 over 9F, plus F sub C. So F sub C therefore is 4 over 9 of F. Then we draw the free body diagram of this portion of the handle with P. So action reaction, F sub C is now 4 over 9F acting at C downward. Then take note that there is horizontal distance between C and D, or D and E, and that distance is 1.5 sine of 15 degrees, this one. So moment d0, clockwise positive, then it is equal to P. The moment arm of P is not 22, it is 22 minus 1.5 sine of 15. So moment d0 equals clockwise positive equals P times quantity 22 inches minus 1.5 in sine 15, then minus 4 over 9F times 1.5 sine of 15 degrees. So from here, we can solve now F in terms of P using your calculator there. So F is equal to 125.3 P. A pair of 80 Newton forces is applied to the handles of the small eyelet squeezer. The block at A slides, this one, there is a slot here, slides with negligible friction in a slot machine in the lower part of the tool. So here, it's free to slide. There's no friction. Neglect the small force of the light return spring AE. So that's the force in this spring is also negligible because it is a light return spring. And determine the compressive force P to the eyelet. So the effect of 80 newtons will cause reaction on this two first body BD here. Compressive force, definitely. Then as a result, that compressive force will push this portion because there's no friction, and it will compress this part here. So the reaction would be compression, and that compressive force is denoted by P. So the plan is we solve first for the compressive force in VD by drawing the FBD of this portion ABC. We sum up moments about A. Then after we solve for that, we draw the FBD of this entire part not touching A, and definitely summation forces horizontal equals 0, and that compressive force is the horizontal component of this force in BD here. So for the solution, let's solve for this angle first that BD makes with horizontal. This is arc tan of 15 plus 6.25, so 21.25 over 50. So that angle is 23.025 degrees with horizontal. Then we replace FBD into components, horizontal and vertical. The horizontal component is FBD cosine of 23.025 degrees, while the vertical component, which is upward, is FPD sine of 23.025 degrees. And these are the reaction components at the pin at A. So moment A is 0, counterclockwise positive. So let's begin with the horizontal component. It is equal to FBD cosine of 23.025 degrees times 15 mm. The distance, vertical distance from B to A is 15 mm. Then plus counterclockwise FBD sine of 23.025 degrees times 62.5 mm. Then minus 80 times 62.5 plus 50 is 112.5. So minus 80 times 112.5 mm. So it's only FBD that is the unknown in this equation. So we can solve for FBD using your calculator there. So FBD is 235.29 newtons. Finally, FBD of this part. So we have P, then FBD, and the angle it makes with horizontal. So R horizontal equals 0, or summation forces horizontal equals 0. Then equals P minus horizontal component of 235.29, which is 235.29 cosine of 23.025. So P therefore is 235.29 cosine of 23.025 degrees, and that is equal to 216.5 newtons. Compute the force in link AB of the lifting tongs which cross without touching. So in this portion, the tongs are not touching. So first we compute the force in CE. By symmetry, it is also equal to the force in DE. Of course, the tension in this cable is equal to 800 pounds, the weight of this crate. Then after that, we resolve this force in CE, draw the free body diagram of this part. We plan to sum up moment about G. So FBD of this joint E first. The angle that CE or DE makes with horizontal is arctan of 12 over 18. And arctan, we have 800 tension, then FCE, FDE. Take note these two are equal by symmetry. And the angle here is arctan of 12 over 18. That's 33.69 degrees. 33.69 degrees. So R vertical equals 0 at E. So we have 800 minus vertical component of FCE times 2 because these two are equal. So 800 minus 2 times vertical component of FCE, which is FCE sine of 33.69 degrees. So FCE therefore is equal to 721.11 pounds. Then we draw the FBD of this part. So we have 721.11. Take note this is 33.69 degrees. Then this is the force in. We remove it, replace by component 721.11 cosine of 33.69 degrees, that's 600 pounds, while 721.11 sine of 33.69 should be half of 800 or 400 pounds. Then this is the force in AB that is required, and at G we have downward force which is definitely 400 and normal force which is to be found. But we plan to sum up moments about G, or MG is a 0. By the way, this distance is 33 inches. 24 and 20 are given already. This 33 inches is from G to the center is half of 30, so 15. Then from center to C horizontally is 18. So 18 plus 15, half of 30, so that's why it's 33 inches here. So moment G is 0, counterclockwise positive, so we have FAB times 24. Then minus 600 times 20 plus 24 is 44. Then minus 400, counterclockwise positive, so this is clockwise. 400 times 33 is also clockwise, so minus 400 times 33. So it's only FAB that is unknown here. Solving for FAB. FAB is 1650 pounds. The machine shown is used for moving heavy items such as pallets or bricks around construction sites. For the horizontal boom position shown, determine the force in each of the two hydraulic cylinders AB. The mass of the boom is 1,500 kilograms with mass center at G1, and the mass of the cube of bricks is 2,000 kilograms with mass center at G2. Take note that there are two hydraulic cylinders. So therefore, the loadings will be transmitted only to portion AB if we divide the masses by 2 or the weights by 2, so that we only transmit the effect of these masses or forces to AB, just AB. Take note there are two cylinders because this is 3D. So theta AB is arctan of 150 plus 890 vertical. 150 mm plus 890, use your calculator that, over 740. So it is 54.567 degrees. So weight 1 is mass divided by 2 times 9.81 in Newton. So 1,500 times 9.81 over 2. We divide it by 2 so that we can solve for the force in AB alone. Take note, there are two cylinders, hydraulic cylinders AB. So we only transmit it to just one. So that's why we divide by 2 the masses. So the weight is 7357.5 newtons or 7.3575 kilonewtons. Weight 2 on the other hand at G2 is 2000 times 9.81 over 2. So that's 9,810 newtons or 9.81 kilonewtons. We then put it on the FPD of this portion. We have O as our moment center here. So we have FAB. Then let's resolve FAB into horizontal and vertical components. The horizontal is FAB cosine of 54.567 leftward, and we expect it to be in compression pointing towards B, the force AB, and the vertical component is FAB sine of 54.567 degrees, and the moment arms are already there. So we transmit weight 1, which is 7.3575 acting at G1, and the distance of 7.3571 horizontally from O is 1.7 plus 0.74 plus 0.6, that is 3.04 as shown. Then for weight to 9.81 kilonewtons, the distance is we just add 3.04 by 3.06 meter. So 3.06 plus 3.04 is 6.1 meter. 9.81 is horizontally 6.1 meters from O. Then we set moment O 0, counterclockwise positive, beginning with horizontal component FAB cosine 54.567 times 0.15, 150 mm or 0.15. Then plus, this is also counterclockwise, the vertical component, plus FAB sine of 54.567 times 0.6, which is this distance here, 0.6. Then minus 7.3575 times 3.04. Then minus 9.81 times 6.1. So it is only FAB that is unknown here. So we can now solve FAB. So FAB is equal to 142.8 kilonewtons compression. So that's it for this first part.